Hi, so this is question 20 from the Tmua 2020 paper 2. Now, these kind of only if, and only if questions always cause a problem. What's important here is this language of exactly one. You can almost guarantee that if you see the language of exactly one is true, you're looking to find out if there are any that could both be true, because if there are, then we can say straight away that, well, since two can't both be true, then they must both be false. Because you can't have two statements both being true, because there's only one true statement. Now, the if and only if one is interesting, because that's essentially, if we look at, pen's too big. If we look at statement F, that says that f of x greater than or equals to 0 is a equivalent statement to x being less than 0. They always happen simultaneously. And you can see that statement B is part of that, because statement B is saying that if f of x is greater than or equal to 0, that implies x is less than 0. So therefore, if f is true, then b is also true, which means neither of them can be true. So we can write off those two straight away. Now, there's no others that are quite as nice as this. But what we also want to think about here is the contrapositive. Now, contrapositive is a really important part of the Tmua specification. If you need reminding of what that is, get the Tmua specification, look up the contrapositive. So if we take statement A, which is working through these in order, we can say that the f of x being less than 0 implies x is greater than or equal to 0. And it's only if, and that only if is going to be important here, because what that means, the contrapositive of that, is if x is less than 0, that implies that f of x must have been greater than 0, because we're saying if f of x less than 0, then x greater or equal to 0. Therefore, the only way x could be less than 0 is if f of x was greater or equal to 0. And we can see that that's going to, that's, hang on, that is also part of f. Yes, so that's the backwards implication of f. So if f is true, then a is also true. So again, we can write off a there. Then, if we look at the contrapositive, the if statements are actually a little bit harder, because that's not saying, it's harder to do a contrapositive of an if. It's easier to do it with an only if, because we're not saying that x less than 0 is the only thing that makes f of x less than 0. Whereas the only, if that D was an only if, it'd be better. So I'm going to look at E. Now, E is saying that x greater than or equal to 0 guarantees f of x greater than or equal to 0, and there's no other way for f of x to be greater than 0. So the contrapositive of that, sorry, this was the contrapositive of A. Contrapositive of A, the contrapositive of E is that if f of x is less than 0, that can only have happened if x is less than 0, because we know it's an only if. Only if x is greater than or equal to 0 do we then have f of x is greater than or equal to 0 as well. And the contrapositive is always true, and the contrapositive here is the same as D. So E and D, there's you can have them both being true. So the only one that's left is C. So we've got C must be the true one. Give me a shout if there's any issues with that, because the contrapositive stuff is hard, but it's such a powerful thing to know. And this exactly one is also hard, but again, it's such a powerful thing to know. It's really what Tmua are going for in terms of the logic.